Hello everyone, my name is Viraj Pramod Parab. I am currently pursuing MSc in Mathematics from IIT Patna. I have done my undergraduate from University of Mumbai. Today I am going to discuss one of the topic of the chapter sequences series, which is arithmetic progression sequences. So let's start with it. So first of all, before jumping into arithmetic progression sequence, let me define what a sequence is. Well, a sequence is an ordered list of numbers. It could be any list of numbers, like for example, it could be a list of constants like 1, 1, 1, or we could start with 1 and then keep incrementing it by 1. So it will be 1, 2, 3, 4. Or we could start with something like 10 and then keep decrementing it by 1. So the sequence will be 10, 9, 8, 7 as in example 3. Or we could start with any given random number like 5 and then keep incrementing by random number like 5. So the sequence will be 5, 10, 15, 20 and so on. Or we could start with a number and then keep multiplying it by a particular number, like start with 2 and then keep multiplying it by 2. So the sequence will be 2, 4, 8, 16. Or it could be a sequence of just random numbers like 1, 4, 6, 7, 2, 0, 198, 64, anything. So the first four examples are example of arithmetic progression sequences, whereas the fifth example is an example of geometric progression sequences. And this is just a random list. Okay, so next we will list down what are the types of sequences. So there are basically three types of sequences that we are going to deal in this chapter. That's the first is arithmetic progression, which we will deal in detail in today's lecture, and in later lectures we will discuss geometric and harmonic progression series. Okay, so what is an arithmetic sequence? Well, an arithmetic sequence is a sequence where the difference between the consecutive terms is constant and the difference is denoted using D, and the first term of the sequence we denote it using A. Like consider for example the sequence 1, 2, 3, 4. Here our first term is 1, so our A is equal to 1, and the difference if you look at it is 2 minus 1, which is 1, and it is constant throughout the sequence, like 3 minus 2 is equal to 1, 4 minus 3 is equal to 1. So this is actually an arithmetic progression sequence with A is equal to 1 and D is equal to 1. Take for another example. Let's say 5, 10, 15, 20. Over here our A is equal to 5 and our common difference is equal to 5. Let's say we start with 8. So our first term is 8 and the difference we can see is 6 minus 8, which is minus 2, right? Similarly, we could also have list of negative numbers which too are sequences like minus 8, minus 6, minus 4, minus 2. Over here, if you note the difference, it is minus 6 minus plus 8, which will be 2, right? Also, the sequence of constant 2 is an AP. Why? Because if you look at it, the difference is constant, it is 0. So that too is an arithmetic progression sequence. Okay, so now that we have uh, formed the notations for our AP sequences, let's find out how we can find the nth term of any given sequence, of an AP sequence. So, as I said, we denote the first term using A. Then the second term will be the first term plus the common difference. So that will be A plus D. Similarly, the third term will be second term plus D, the common difference. So that will be A plus 2D. The fourth term will be A plus 3D. Notice a pattern over here. The nth term is equal to A plus n minus 1 into D. And that's actually our formula. The nth term we give using A plus n minus 1 into D. Okay, so now that we know how to denote the nth term, let's jump into how we can find the sum of first n terms of an AP sequence. So over here I have sequence like 1, 2, 3, 4, 5, 6, which I have denoted using boxes, right? So this is one sequence. What I'm going to do is I'm going to take this pile of boxes, I'm going to reverse it and pile it on top of it, like something like this. As you can see, if you observe closely, you will see that the first term and the last term, the sum of this pair is always equal. Like if you take the first term and the last term, and the second term and the second last term, the sum of those pair will be equal. Similarly, the sum of the third term and the third last term too will be equal. So what we get is a rectangle, right, of width n, which is like the number of terms, and what will be the height? It is a sum of the first and the last term, so that will be a1 plus the nth term, which is the last term, right? And this is a rectangle over where we can see that we are basically using the number twice, right? So it will be twice of the sum of first n terms, and this is the rectangle, so the area of the rectangle will be width into height, which is n into a1 plus an. So our sum of first n terms will be n by 2 into a1 plus an. Well, we know that the nth term is given using a plus n minus 1 into d. So our sum will be n by 2 into 2a plus n minus 1 into d. And that's our formula for the sum of first n terms. Okay, so now that we have discussed all of the concepts of AP, let's solve some of the problems. Our first question has appeared in the 2019 session, and it says that we are given that the 19th term of our non-zero AP is 0, and we are told to find the ratio of 49th term to the 29th term. Here are the options. Pause the video and give it a try. Okay, so now let's look at the solution. So first of all, we are given that the 19th term is 0. That means A19 is equal to 0. What's the formula for A19? It will be A plus n minus 1 to d, which is A plus 18d is equal to 0. So our first term is equal to minus 18 into the difference, right? Now, we want to find the ratio of the 49th term to the 29th term. How could I denote 49th term? A plus 48d. Now I know that the A is minus 18d, so just substitute over here, and you'll get that the 49th term is equal to 30 into difference. Similarly, the 29th term too will be 10 into the difference. Now to find the ratio, it will be 30d divided by 10d. Now notice that we are given that the AP is non-zero, so the difference too will be non-zero definitely. So we can cancel the d out and we will get that the ratio is 3:1, which is our option C. So that is the correct option. Okay, so now let's move on to the next question. Okay, so our next question has appeared in the 2025 session, which is very recent. And over here, we are given that the sum of first n terms is equal to 700, the sixth term is 7, and the sum of first 7 terms is equal to 7. And we are told to find the nth term, right? And these are the options. Pause the video and give it a try. Okay, so now let's solve it. Well, first of all, we are given that the sum of first 7 terms is equal to 7. So we can apply the formula and we will get that the A and a plus cd is equal to 1, which is one equation. We could also utilize that the sixth term is equal to 7. Over here, we will get the second equation. Now we have two equations and two unknown variables which we can solve, and we will get that the a is equal to what? It is minus 8 and d is equal to 3. Now we have a and we have d. We want to find the nth term. What's the next step? Well, we need to find the n, the number of terms, right? So for that, we can use the information that the sum of first n terms is equal to 700. Just utilize it in the formula and you will get a quadratic equation like this. Now once you factor this out, you will get that the n is equal to 25, right? So now just apply the formula and get the nth term, which is the 25th term. Now once you apply the formula, you will get that the 25th term is equal to 64, and the correct option is 64, which is the D option. Let's move on to the next question, which is a numerical answer type, and it has appeared in the 2025 session. Over here, we are given the interior angles of a polygon with n sides in arithmetic progression, with a common difference of 6 degree, and the largest angle is 219 degree. Now notice that we are given that the interior angles, so definitely they will have to be positive, and also we are given that the difference too is positive. Now if an AP has the first term is positive and the difference too is positive, then definitely the largest term would lie at the very end of the list, right? So our nth term will be actually 219, which is the largest. So we can utilize this information and we'll get that the a plus n minus 22d is equal to 219. So a is equal to 225 minus 6n, right? Now we know that the sum of the interior angles of a polygon with n sides are n minus 2 into 180. So you will equalize that with our formula and you will get that there are basically you will form a quadratic equations which you could then factor out to get that the n is equal to either 20 or minus 6. Now definitely the number of sides cannot be negative, so 20 is our correct options, and that's the correct result for this given problem. Now here are some problems for you to try on. These are the practice problems. All of these questions have appeared in the 2025 sessions, and I have marked the correct options with bold boxes so that you can check whether your answers are correct or not. Please give it a try, and in the next lecture, we will discuss geometric progression. Thank you.